Hello, everybody. Thank you so much for coming today. I really appreciate it. My name is Dennis Willett, and I work at the North Carolina Institute for Climate Studies. I'm super excited to chat with you all today about multi-account deployments, how we can stack accounts in a single stack so that we can better manage things like cross-account monitoring, management, and more. So to get us started today, I'd like you all to imagine a world where all of the major clouds play nicely together. Many of you have experience working in Azure, AWS, and Google, among many other different cloud platforms. We do as well, and because of the nature of our work, we work across all of these three different cloud platforms. And one of the challenges for the type of work that we do is actually getting them to play nicely together and to talk to each other. And that's really where Pulumi has come in to help us out. Pulumi's been a lifesaver in certain aspects because it allows us to take care of this garden of multiple clouds all in one place. We can water them effectively together and work with them in sort of this unified framework that allows us to manage them much more coherently. So that's what we're going to be talking about today, basically how we can manage multiple accounts across different clouds and regions in a single stack, a single Pulumi stack, so that we can do things like cross-account monitoring and management. To kind of understand the background of this and understand why this is important, we're first going to dive into the why you might want to actually manage the multiple accounts in a single stack. Then we're going to dive into actually how we do this, looking at some code snippets and talking about some of the key features of Pulumi that make this possible. And then we're going to talk about the impact that this has had on us and our organization. So to start with the why. Why might you want to actually manage multiple accounts, regions, etc. in a single stack? And at the North Carolina Institute for Climate Studies, this was actually something that we were really looking for in an infrastructure as code provider. Our work focuses on understanding our planet at scale. Everything from the bottom of the oceans to the soil that sustains life on the terrestrial part of the planet to the atmosphere at sort of the global scale as well. And we really want to understand our planet at scale so that we can understand the climate-related risks that we face moving into the future. Many of you, if you've been paying attention to the news or have lived in these areas, are well aware that our planet is changing. It's changing drastically and sometimes with devastating impacts on humans. We get to look forward to this much more in the coming decades, and our job at the Institute here at North Carolina State University is to become prepared for that. The idea is that we can use this knowledge to make a better future for ourselves, be more prepared for when events like this happen with unerring and much more increasing frequency and intensity, so that we can better prepare ourselves and future generations as well. The way we do this is we work on kind of four key areas. We deliver highly impactful national climate assessments. We work extensively in the open data realm. We conduct research in climate science, and we invest heavily in workforce development. And in all of these, we utilize cloud platforms to leverage our data, our skills to be able to scale as well. One of the key programs that we work on and we manage is the NOAA Open Data Dissemination Program. The goal of this program is to make all of NOAA's data publicly available on the three major public clouds. And the way that this works is NOAA, because of the extensive resources that they have, run a number of sensing platforms, satellites, weather stations, sensors in the oceans, etc. And our job at the North Carolina Institute of Climate Studies is to be their data broker, where we have privileged access to NOAA systems, and we help move all of that data to the three major clouds: Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And we literally try to do this for all of NOAA data. So today, we manage over 300 NOAA data sets on Amazon, Azure, and Google. This ranges from everything from atmospheric data sets, models, a whole bunch of information about the oceans, bathymetry scans, climate projections, near real-time data that come in every second, models that are run once a year. It's a wide range of data that basically spans the entire planet on any given day and is quite extensive. It's used by Fortune 100 corporations, federal governments, researchers around the world on a daily basis. We currently manage 60 petabytes of this data across those three cloud platforms, and our platform supports a petabyte a day of access and over 1 billion requests per day. All of this is free and publicly accessible. Anybody can go to this website here, access the data, and run with it and use it for various applications. Happy to talk about that more. The goal for this talk is to highlight what the needs are basically to manage a platform this size at scale. So in managing this for the NOAA Open Data Dissemination Program, we have a number of needs in terms of the scale of our platform and how we can manage this interacting with NOAA on-prem systems and then the cloud systems. Just by the nature of what we've been tasked to do, we manage multiple clouds. So we manage platforms on Amazon, Google, and Azure. And on each of these different clouds, because of the nature of the funding and the support for this program, we have multiple accounts, ranging from accounts to do specific pipelines to massive accounts to do separate data sets. And we run this in multiple regions depending on when the data come available, where they become available, and to whom they're going to be provided. So just by the very nature of this program, we are by necessity dealing with multiple clouds, multiple accounts, and multiple regions. This becomes a management challenge because not only do we have multiple clouds, accounts, and regions, but we also need to build, deploy, manage applications, platforms, and have a wide variety of needs spanning the multiple clouds, accounts, and regions. Not only for data pipelining reasons, but also for management applications as well. Because we deal with these three different cloud service providers and we deal with NOAA and on-prem systems, we are tasked with basically connecting all of these pieces together into a coherent whole, and ideally doing it without much of a management headache. And so some of the key needs that we have working across these multiple clouds, accounts, and regions is we want organization-wide visibility. We need to be able to basically look at all of our resources across all of these different accounts and regions and be able to understand not only what's out there, but how do we begin to automate deployments, updates, etc. across these multiple clouds, accounts, and regions as well. This is not only sort of useful from a productivity standpoint, but it also allows us to implement standards enforcement, which is really, really crucial, especially when we're dealing with the type of data that we do. We want to make sure that the user experience is seamless and that standards are kind of enforced and baselined across the entire organization, across these multiple clouds, accounts, and regions as well. In addition, we also have management challenges because across all of these different platforms, we want to sort of seamlessly manage identity. This is everything from who's able to log in and access, but also the different roles, responsibilities, and permissions that are out there as well for managing the pipelines and for managing the data. In addition, across these different clouds, accounts, and regions, we have pipelines. Some of the pipelines actually span accounts and regions as well. And there's a suite of common services that we need to sort of manage and deploy across this platform as well. We want to be able to leverage these common services across the different clouds, across the different accounts, and across the different regions as well. So when we begin to think about the scale of the management challenge that we have here, we not only want to be able to have sort of seamless monitoring capabilities, but also seamless management capabilities across these different accounts, regions, and clouds. And this is kind of where Pulumi comes in and really helps us out here. When we were looking at infrastructure as code tools, we were really concerned about how we would actually begin managing this because a lot of the examples that we saw did not necessarily highlight the sort of the multi-stack capabilities in terms of having multiple accounts in a single stack. And this is where Pulumi is the superhero of the day. So we extensively leverage Pulumi to be able to basically help with those monitoring and management challenges across these multiple clouds as well. So when we were looking at an infrastructure as code provider to help out with these management challenges and sort of begin to scale this platform, we looked at a number of different options and really were excited about Pulumi because it had Python as sort of first-class support. All of our developers were Python-based, and this allowed us to ramp very, very quickly in this infrastructure as code paradigm. Also, one of the things we really liked about Pulumi as well is that it has first-class support for the three major public clouds, so AWS, Azure, and GCP. Really, really well fleshed out ecosystems there, and all in Python as well. Not necessarily the case for some other IAC providers. The other thing that we really liked and picked up on with Pulumi is that there were a lot of different people in the community working with Pulumi. Some of them were web developers, some were really focused on data engineering, others really looked at full stack applications as well. And this was great for us because we actually deploy all of these different things, and because there was a lot of extra community support and Pulumi was able to sort of be applied across these different applications, it seemed like a really good fit. We were also really excited about sort of how Pulumi thought about stacks. And so as many of you are probably aware, stack is a very sort of common unit in a Pulumi program. And so these are sort of isolated independent instances of Pulumi programs where the resources are all collected in a single stack. Usually stacks, and a lot of the documentation out there for Pulumi and in the community is really focused on a single stack where there's a stack for development, staging, and production, or for specific feature branches. They're very isolated. And basically what we've begun to think of is a stack as a collection of resources. And once you have this collection of resources, you can begin to think about how to organize your resources into stacks. And then you begin to think that stacks are really just related collections of resources. Usually though, especially if you're dealing in the dev test prod or dev stage prod paradigm, you typically have a stack of related collections of resources where they're all on the same cloud, they're all in the same account, and they're all in the same region. This, though, doesn't really necessarily map to what we need to do for our program, where we're taking all of NOAA data and moving it to the public clouds. What we begin to think about is simple stacks are great, right? Simple stacks are isolated applications. You can move them very seamlessly between dev, test, and prod accounts. They're replicable across regions. And for most use cases, a single application, this is the best option, hands down. And so that was a really clear sort of win with Pulumi, very sort of made sense, immediately applicable for some of our things, but we were still trying to look for this other option. And one of the things we really liked about Pulumi was the way that it supports what we're calling super stacks. These allow you to have related collections of resources in a single stack, but importantly across multiple accounts. And so super stacks allow you to enable organization-wide monitoring and management. There tend to be limited use cases for this, but they're actually incredibly powerful. And because of the nature of the challenge that we had in managing this organization, we actually rely heavily on these super stacks to manage our resources across regions, across accounts, etc. And the reason for that is because for our applications, these super stacks allow us to not only work on multiple clouds, accounts, and regions, but build applications, platforms, and actually manage these needs spanning multiple clouds, accounts, and regions in a single Pulumi stack. What this does is it gives us a single point of truth, a single place to go, a single pane of glass into a given application or need, even though that application or need actually spans multiple clouds, accounts, and regions. And that is really where the power of this comes in, and why I'm really excited to talk to you about these multi-account deployments, because what we're able to do with these super stacks in Pulumi is to be able to leverage monitoring and management platforms across all of our different accounts, across our different regions, in a single place that allows for very, very cohesive management. So that's a little bit of the background about why we wanted to do this. Now, how did we actually go and implement it? And so let's take a look at that really quick as just a quick example about how to set this up. As we mentioned, typically with a simple stack, you have one cloud, one account, one region, importantly, one set of credentials, and these are all defined and tied to a single stack. If you're using Pulumi CLI, it's probably in something like pulumi.dev.yaml. Everything is there, you get it up and going, you launch it. If you need to change it later, you can move it between accounts and regions. Everything's there. That's great. Very, very common use case, very useful. We're actually very much interested in super stacks, where we're able to combine multiple accounts, regions, clouds in a single stack, where we have one Pulumi stack that manages all of these different resources. They're all related, they're all connected, but the trick is we have many credentials. And so when we begin to look at how to actually implement a super stack, we have a couple of tools that are super helpful for us. So one is the Pulumi Automation API. This really allows us to seamlessly put together multiple providers, which are the way that Pulumi connects to different accounts, regions, etc., and to do it seamlessly in CI/CD pipelines. So what this allows us to have basically is in our GitLab repo with these different super stacks, it's all managed by CI/CD, and the Automation API allows us to manage these multiple providers very, very seamlessly. Let's take a look at exactly how this works. Once we have a super stack and we want to build an application spanning multiple clouds, accounts, and regions with many credentials, we can do it with a specific use case. So let's take a look at a use case of monitoring. Let's say we want to put a cross-account read-only access user out there. For the use case we're going to do, it's just going to be on AWS across multiple accounts and regions. Once we have that, we can use that read-only access to use things like Steam Pipe for monitoring, other monitoring applications once we have visibility into those accounts. The way we're actually going to go about building this is by first, we're going to configure and set up our automation API. Once we have that, we can provide account information about all the different accounts that we want to access. We can configure that account information with Pulumi providers so that Pulumi provider knows which accounts to deploy the resources to, and then we can actually deploy the resources as we need to, sort of on demand in our stack. So that's the roadmap of where we're going. To build this out. Let's get started with the automation API. So to get started with the automation API, pretty straightforward, boilerplate code. Pulumi has some great documentation on this. First, we set up our stack name. In this case, we're going to be running an NKIX monitoring stack. Weird if we're doing it in a prod environment. So this is the example here. We're going to launch this monitoring stack here, and then we're going to launch our Pulumi resources, install the necessary plugins, refresh preview, and launch the stack in sort of our main, again, this is all in Python, in sort of our main function here. We're good to go. We've connected to Pulumi, and we're set and connected into the automation API. So in our launch Pulumi resources function, we'll be able to stand up the resources that we need. Once we have the automation API working, we can go out and get all of the different account information. So one thing we can do is we can go and connect to our top level AWS organization and list all of the accounts that are available there. This is just using Boto 3. We'll dump those accounts into a dict that we'll be able to iterate through in a bit. Once we have those list of accounts, we can use this and then selectively access those accounts to deploy those resources. Again, this is using Boto 3 to do it. Number of other different ways to do it. We're in Python here, so that's what we're doing. Once we have the account information, this is where the sort of the secret sauce comes in. We can use Pulumi providers. And what Pulumi providers allow you to do to connect to specific accounts, resources, and regions, you can define all of that in a specific provider. You can do this for Azure, you can do this for Google, you can do this for a number of other different platforms, and you can also do this for AWS like we're doing here. So we're setting up our organization account access role that allows us to be able to jump between accounts. We have our AWS provider. We can specify a region. We can specify a role. You can also explicitly pass in credentials. You can also create multiple account providers. You can do it per cloud and per region as well. All of that is explicitly defined in a provider. And once you have this provider, you can pass that in to the different resources to make sure that those resources are launched on that specific account. Deploy. So for what we're going to do, let's say we want to deploy this read-only monitoring access across all of our different accounts. We've gotten our accounts from the high-level AWS organization. We have our role. We set up the provider using that information on the previous slide, and then we can create a monitoring role with read-only access. So we can create this IAM role. The key trick here is that we can pass in that current provider, which is linked to that specific account, as ops in that options there in that function, and that monitoring will be applied specifically into that account. And again, you can do this with different regions that can all be made explicit, different clouds, etc. What this allows us to do is very seamlessly loop through all of our accounts, automatically deploy read-only access user IAM role in there, and be good to go because it's all tied to that provider that is iteratively created on the fly as we look through that, all in a single stack, all in a single location in GitLab where it's all version controlled, but accessing multiple accounts in that single Pulumi stack. This allows us to basically put that in a single Python script, one super stack where we're able to access via the providers and the automation API, multiple clouds, accounts, regions, etc. All good to go, CI/CD pipeline, we're off to the races. And so this has been incredibly powerful for us in terms of how we actually manage those resources. It's also had a tremendous impact on our team. So the first and foremost, this is incredible for sanity, right? So this gives us one location, one primary point where we can go in, look at the resources that we have, manage them. Because we're using the control structures in Python, we can very rapidly add new accounts, just destroy, have access across all of our different accounts, regions, and cloud providers. This allows us at our institute to manage 45 different accounts across 7 different regions and across 3 clouds with 60 petabytes of data and $1.4 million a month. And this allows us to do it in sort of the same way where we have these single points of truth, all managed in version control in GitLab, connected with Pulumi, and allows us to do this with only 3 people. So this is the power of multi-account deployments. I really appreciate your time today. If you're interested in chatting more about this, please reach out. Check us out. We're the North Carolina Institute for Climate Studies, and looking forward to chatting more with you later. Thank you.